All right, hi. This is the group Choose at Will. We are doing the video processing final project. Group members Safa Bakshi, Chase Brookman, and Jazdeep Chera. This is our MATLAB project, and we'll be going more in depth into all functions shortly. All right, so here we're going to be showing off the program itself. We run it. Here we have the GUI. It's beautiful. Here we go. We're going to load in our videos. It's called Star Wars. It's a great scene. So here we have a functional scroll bar that can scroll to any frame. We can enable an RGB histogram. Here we can play the video. You can hear the audio right now. This will mute it. You can still hear my voice. You know it's muted because of that. This has a step back function where it steps back one frame at a time. Has a step forward as well. What you're seeing right now is some lag on the MATLAB processor. What it can also do is once we press stop, it goes all the way to the back. And to test the step back, we can also step back here. It does nothing. You do the step forward at the end of the video. Nothing happens. And yeah, you play it. The audio is working fine. RGB display. That's about it. And now we'll be going into the code behind every button and sort of the program. All right, now we're going to be going into the load function of the program. Here we have the load button callback, and we have the global R for audio. Here we have the UIGet file function, where we get the video file itself. It can be M4V, MP4, MPG, and AVI. We then put the file name together with the string concaction. Here we have the video reader that reads the video, and the audio reader as well. The audio is synced in our videos, in all videos played. Wonderful, A+. Here we have further setting of handles to sort of gather the information from the video, including frame rate, duration. And down here we have further string work to properly display all the information of the video, including frame rate, resolution, duration, and that's the load function.
Hi, this is Safa Bakshi, and I was responsible for doing the play pause button functionality of our project. This is our play button callback function, and the first thing we do is we get our video data and audio data from handles and global R. The next thing we do is we check to see if the button's user data was set at pause, stop or pause, or play. And based off of that, we set the button's user data to the exact opposite, play or pause, and the string to play or pause. Then we begin our video playback loop. The condition for a playback loop is that our video has frames left and as user data of the play button is set to pause. The most important thing that we do is we take the time using tick to measure the elapsed time it takes to render one frame in our playback loop. Then we read a frame using read frame, and then we set that frame to the axes using image of frame. Then this code right here is used to set our histogram, which we'll get into later. And then once we're done with that, we'll take delta equals talk to take the elapsed time it takes to run all of that code since tick. Next thing we have to do is we have to pause our video for the 1 over the frame rate minus that time it took to render all of this code right here, so that our frame rate appears correct in the process.
Hi, I'm Chase Brookman, and I am responsible for the functionality of the stop button. For the stop button, we first got our global variable R and stopped R, which was the audio. Right after that, we stopped the video and set the current time of the video to 0, and then read the frame, which is the first frame of the video. So it's displaying the first frame ready to be played. Down here, we can see code for the histogram, and that will be coming up in just a sec. Alright, so for the histogram, we wanted to create blank axes so the numbers wouldn't keep showing up and changing rapidly. So what we did here in the histogram code, we added an X tick and a Y tick and set those to blank, so that way our graphs would not have axes on them.
Hey, it's Jazdeep. You can call me Jazz. I'm going to go over the step back and step forward functions of our program. Here we have the logic, including sort of how long one frame takes and that sort of whole process of going through the steps. We have our implementation as one step forward, or one frame forward and one frame back. And once again, here's our logic to show that. We use the set handle buttons to change the strings for the buttons when we press them. We also constantly are reading the frames and the scroll bar is also being constantly updated. Here's the histogram, which will be explained later. Here's the step back code for the push button 10 callback. It's a very similar code to the step forward, just we're stepping back this time, one frame at a time. We do read the frames a lot more frequently here. That's to avoid some errors we came up with in our code. And we do make sure our variables are set, and we do repeat those several times. And then here are set handle codes. And once again, down here, we have histogram code that Chase Brookman will be going over shortly.
Hi, this is Safa. I'm going to explain to you how the slider functionality works in our project. So the first part of our slider functionality involves updating the slider in real time. That is done by setting the value of the slider to the video's current time in the playback loop so that on every frame the slider updates. Then, when the user decides to move the slider, we run our slider execute callback function. Over there is when we get our value of the user's slider position and store it to h, and then set the video's current time to that position. We also check to see if h is equal to 0, we like to set that current time is equal to 0. And if h is equal to the maximum point of the slider, we set the max time of the video. And then otherwise, we simply set the current time of the video to h and print that frame out and pause the video, of course. So you can see right here is that the video is paused when you do move the slider. So keep that in mind when using the program. Now I'll explain the audio functionality of our program. So as you recall, in the load function, we created an audio player called R. So when the user clicks the play button, the first thing we do is we play the audio using the play command, and we play that audio at the current time of the video. Then in our while loop, we have two corrections for our audio sync. Our first correction is a while loop that corrects for audio overrun when the audio is ahead of the video. The first thing we do is we check to see while our audio's current time is ahead of our video's current time, and we check to see if the difference between those are bigger than 1 over the frame rate. What we do is we advance the video by an extra frame to help it catch up to the audio, and we keep doing this until the audio and video are in sync. Then later down, we have an if statement down here that corrects for audio underrun when the audio is behind the video. First we do is our if statement checks to see how much that current video time is ahead of the audio time, and then we pause the video for the amount of that difference in order to correct for time. Our audio feature also has a mute button. The mute button functionality is located in the mute button callback function. Mute button callback function uses similar logic to the play pause functionality and uses a get data of the user data to versus unmute versus mute to change the functionality of that button. What the mute button does is it stops the audio R and sets the button to unmute. Then otherwise, the video is then played for unmute at the current time of the video.
Yeah, all right, this is Chase, back again to tell you about the histogram. So for the histogram, we learned earlier that the video works by running through each frame one at a time. So for the histogram, we assigned an array for each of the colors in the RGB for each frame. So we have red, green, and blue right here. From there, we created a histogram for each red, green, and blue, and then plotted them all on one axis. And then, as talked about earlier, we mentioned that in order to remove the axes or the numbers on the axis, we set the x tick and y tick to 0. And now underneath here, we see that when the histogram is not enabled, we've plotted nothing so that it just shows up blank on the axis. Thank you, and have a great day.